Today we will start with the chemical reactions of the carboxylic acid. First, let us see such reactions in which the OH bond is being broken. The bond between oxygen and hydrogen will be broken from the carboxylic acid. So we have three sets of reactions here. The first one is reacting with a metal, sodium metal, and you should know that when it is reacting with metal or with an alkali of that particular metal, as well as the hydrogen carbonate or bicarbonate, you can say, in such cases sodium salt or the respective salt of the metal will be formed. So here, since we have taken the sodium metal for these reactions, so you will get the sodium salt. When the carboxylic acid is treated with sodium, the OH bond will be broken. For all this set of reactions, the OH bond will be broken and that hydrogen is replaced with sodium. So this case is similar. The product is similar for all these three reactions, but the byproduct differs because we have used different reagents, right? So when we have used 2 sodium metal, you will get hydrogen as byproduct, and this is sodium carboxylate. This is a salt, right? Sodium salt. Similarly, when we have taken the sodium alkali, that is your sodium hydroxide, we will get again sodium carboxylate, sodium salt plus water. When we have used an alkali, we will get water. When you will use sodium bicarbonate, you will get water and carbon dioxide. Since here carbonate is present, so a product will be carbon dioxide, right? And in case of alkali and sodium bicarbonate, one yield is common, byproduct is common, that is the water. So these three reactions suggest that the OH bond is being broken and the metal is replacing the hydrogen. Okay, so electropositive metal is replacing the hydrogen, so you should remember this point here. The next reaction is formation of anhydride from carboxylic acids. So this is a preparation of anhydride, but it is a chemical property or chemical reaction of the acid. Now we have taken ethanoic acid. Now you don't have to get confused because of the structure, because this is nothing but the arrangement of the compound is done in such a way that it is better to explain it. Okay, now you can write here CH3COOH. You can write that way also, no problem, but it helps us, if you write this way, it helps us to understand from which part of the compound the water molecule will be removed in the formation of anhydride. And for executing this type of reactions, an acid is used for which H positive is the major part playing in case of acid. So in place of acid you can write H positive, and the acid can be sulfuric acid, or in place of sulfuric acid you can also use the phosphorus pentaoxide, and the common thing is that you have to heat it heat it in both the cases. Now 2 molecules of ethanoic acid is being taken, and since we are using the water, we are heating it, so water molecule will be released. Now the bond between this carbon and this OH will be broken for suppose, and what is released? OH is released, and from here suppose hydrogen is released, so one water molecule will be released in this case, and then what is left? This oxygen is left only. Okay, so the 2 carbons from the 2 ethanoic molecules will be connected with the one single atom that is left. So this is ethanoic anhydride. In the last class probably, or in the last to last class, we have discussed the structure of anhydride. So I hope this is clear to you all how we have got the ethanoic anhydride. Next is the esterification. So carboxylic acids are esterified with alcohols or phenols in the presence of a mineral acid. So for making it ester, what we need alcohol or phenol in the presence of mineral acid. So this is actually a case of preparation of ester. Yes, a preparation of ester, or property of carboxylic acid or property of alcohol. This reaction you have already studied in the parts of alcohol or phenol. So when carboxylic acid is treated with alcohol, these two are the general structures. In place of R you can use the alkyl or the aryl groups. Okay, and it is treated in the presence of an acid like sulfuric acid or hydrochloric acid. and it acts as a catalyst. So you will get the ester, that is RCOO dash. This is the R dash, and why it is representing as R and R dash, don't get confused, because this R and this R might be different, right? If it is here CH3, it can be here CH2, CH3, right? So both these are different alkyl groups, and in order to differentiate between them, there is a sign, that is your R. Therefore R dash is being used here, and here also one water molecule will be released. So now we have studied about two reactions where one molecule of water is released, and you have to arrange it that way. These three set of reactions are very important from your examination point of view, and hence please keep concentration while studying this. Okay, so there are three reagents that we are going to use now, that is your phosphorus pentachloride, phosphorus trichloride, then thionyl chloride. Okay, so this is the thionyl chloride, remember the name, and we are going to use the carboxylic acid with these reagents. Let us see what happens. When phosphorus pentachloride is used, you will get, see, the products, the major products are similar in all the cases. You will get always acyl chloride, right? So you will get RCOCl. Now this is phosphoryl chloride, POCl3. When you are using pentachloride, you will get POCl3, that is your phosphoryl chloride plus hydrochloric acid. And when you are using trichloride, phosphorus trichloride, you will get, this is phosphorus acid, H3PO3. H3PO3 is the phosphorus acid, and there is no hydrochloric acid. When you are using thionyl chloride, you will get the byproduct as sulfur dioxide and hydrochloric acid, along with the major production of acyl chloride. So when acid is treated with phosphorus pentachloride, you will get acyl chloride, then phosphoryl chloride and hydrochloric acid. When it is treated with trichloride, you will get phosphorus trichloride, you will get phosphorus acid and then acyl chloride. And when it is treated with thionyl chloride, you will get acyl chloride plus sulfur dioxide plus HCl. So you can remember it this way, that when 5 chloride is used here, you will get more products. Okay, when 5 chloride is used here, you will get Cl3. From Cl5 up to Cl3, 2 is reduced here. Like that also you can remember some hint you use to remember the reaction. And when you are using 3, there is no point of getting Cl0, right? Because here we have decreased by 5. Here when 5 Cl is used, you will get 3Cl. When 3Cl is used, there will be no left of Cl. Okay, I'm not talking about the major product because this is easier to remember. The byproducts are mostly difficult to remember. So here you will get some other compound only. You can't even write it down, like imagine it anyways. So this is phosphorus acid is used here, and when sulfur is used in the compound, you will get sulfur dioxide along with the preparation of HCl. So this was just a hint how you can like study the reactions. You use your own technique to remember this. Now when a reaction with ammonia is done, when carboxylic acid is treated with ammonia, it will give ammonium salt, okay, which on further heating at higher temperature gives the respective amides. So initially we will get the ammonium salt, which is the ammonium acetate. Okay, and when it is heated further, the water molecule is released. So you will get CH3CO and H2. Right, so from 4 hydrogen, 2 hydrogen is released in the water molecule and 1 oxygen is used up. So you will be left with C single bond, the single oxygen, and then NH2 is left. So this is acetamide. When carboxylic acid and when amine together form a compound that is known as amide. Okay, carboxylic acid plus amine, that is your acetamide. Amide is formed. And if we are taking a cyclic acid, that is your benzoic acid plus ammonia, you will get ammonium benzoate. So similar case, right? In place of CH3, now a ring structure is there. So other things will be exactly as it is. Again here water molecule is released. the evaporation, you can say in short, evaporation is taking place, water molecule will be released, and we are left with Benjamide, okay, CONH2. So you can see that in both the cases the reaction is similar, except the alkyl group is changing here. In place of CH3 you are using the cyclic structure. Now what happens if two functional groups are attached? The reaction is similar up to here only. In both the COOH, you will first get ammonium phthalate, like NH4 will be placed in place of the hydrogen, like when we have used the sodium metal, we used to replace the electropositive metal with the hydrogen with hydrogen in place of hydrogen. Now since we are using NH3, the basic radical is NH4 for this NH3, right? So and that basic radical will replace the H positive in both these functional groups, and when you will do extensive heating, water molecule was released, but now two functional groups are here now, so two water molecule will get released from both these two functional groups, so you will get thalamide. Now from this thalamide also, if you heat it more, what is released? NH3 is released on strong heating. So now you just subtract NH3 from this whole compound. If you subtract NH3 from here, what is left? CO is left, right? And then CO is left, N is left, and one hydrogen is left, because two hydrogen is there, and from here one hydrogen. Total 3 hydrogen will be released and one nitrogen will be released, NH3. So here you see these two carbons will be binded with the NH, right? What is left? This NH is left now, so this NH will use to connect these two carbons here, and this compound is known as the thalamide. So it can be like write the preparation of thalamide. So this is the reaction how you can obtain thalamide. Let's talk about the reduction of carboxylic acid. What happens when a carboxylic acid is reduced? What product is formed? So when carboxylic acid is reduced with the presence of lithium, aluminum hydride or ether, or this is diborane, and what is being used? Either you can use lithium, aluminum hydride, ether, or in place of ether you can use also diborane, okay? And then one acid is being used here, so you will get the alcohol, the respective alcohol. Here one important note, you can say that we have also studied as well, this is not just a new thing that I am saying, you have already studied it in parts of alcohol. So when alcohol was oxidized, carboxylic acid was produced. Now when carboxylic acid is reduced, what is there? Alcohol is present, okay? Alcohol will be produced. Now decarboxylation. Carboxylic acids lose carbon dioxide. So we are talking about decarboxylation, means carbon dioxide will be released to form hydrocarbons when their sodium salts are heated with soda lime. Now no need to know so much of the thing, you just remember the reaction and you just give a one take of reading for this, okay? Otherwise if you remember the reaction, you can write the literature part by yourself, okay? Remembering the reaction is important than just mugging up this whole part. If you know how to write the reaction, or if you know how to write the product from a reaction, then this thing will be clear to you. But if you know only this thing, you might not be able to write the reaction properly, because you have to remember the formulas, you have to remember the compounds, you have to remember the reagents formulas as well, right? So let us go to the reaction. This is a sodium salt, right? Sodium carboxylic salt, and when sodium carboxylic salt is heated with the presence of sodium hydroxide and calcium hydroxide, this sodium hydroxide will be present in the ratio of 3:1. If suppose calcium oxide is 2, then sodium hydroxide will be 6. If calcium hydroxide is 3, sodium hydroxide will be present in the unit of 9, right? So this is present in the unit of 3:1, in the ratio of 3:1, and this together is known as the soda lime. So like that you have to remember the reaction. You can study the reaction, no problem. The thing is that you have to understand it in a better way. When carboxylic acid is treated with soda lime in presence of heat, what happens? A hydrocarbon is produced, right? So RH is produced plus sodium this is sodium carbonate, Na2CO3. So sodium carbonate is released here. In this chapter, we have also known about the alpha hydrogen, alpha carbon, and this is the last thing about alpha hydrogen that you will be studying. And this specific reaction is the important reaction, and the name is Hall-Vollard-Zalensky reaction. In short, in the examination they might not give you the full name, you have to remember it as HVZ reaction. Okay, Hall-Vollard-Zalensky reaction. Let us see what happens in this reaction. Carboxylic acids having an alpha hydrogen. So you see, when you used to write the reactions, they always used to mention RCOOH, right? But here they have specifically mentioned one carbon extra because we need that carbon, right? We need that alpha carbon and alpha hydrogen. So they have shown here are halogenated at the alpha position on treatment with chlorine or bromine. In the, we need a halogen, it means, okay, in the presence of small amount of red phosphorus to give alpha halocarboxylic acids. Means at the alpha position one halogen will be attached, and that compound should be in the form of carboxylic acid. We are not converting the compound into carboxylic acid to like alcohol or esters. The compound will be as it is, but one important thing will happen is that in the alpha position one halogen will be attached. And this reaction, you see, we have studied so many things in this one line about alpha hydrogen. We have talked about chlorine, bromine, red phosphorus, alpha halocarboxylic acid. The simple thing you can say that you have taken a carboxylic acid where one alpha carbon is there, no, and at that position, at that alpha position only one halogen will be attached. And if we are using one halogen to for that attachment, we will need one halogen from outside, right? So this is basically the thing here. So we have taken our respective carboxylic acid, we have taken where this is the alpha carbon, right? And then we have used the red phosphorus. X2 is what? This is the halogen is used, right? If you want to make like, if you want to make chlorine compound, then you can use chlorine. If you want to make bromine, then you can use bromine. It depends on the scientist, whatever they are using, that compound will be. So red phosphorus is used as well, and water, it means hydrolyzed. Okay, the compound is hydrolyzed. In that case you will get RCH, C double bond O, C double bond O, OH, right? So as I have said, the reaction is very simple. If you study the literature, it seems like it's a very big reaction. It's nothing like that. In place of this alpha, in alpha position means alpha carbon, one halogen will be attached, right? Total you count now, this is the first bond, 1 bond with hydrogen, 2 bond, total 3, 4 bond and 5. So this is not possible in case of carbon, so one hydrogen will be removed from here. Okay, so you will get RCH, C double bond O, OH, and X will be attached here. So this is a easy reaction. It is an easy reaction, Hall-Vollard-Zalensky reaction, or you can say HVZ reaction. The last reaction of this chapter, that is the ring substitution. So you can see we have taken one benzoic acid, and for your information, this benzoic acid, this functional group C double OH, this acts as a meta directing group. So whatever incoming electrophile or nucleophile is coming, it will directly tell the nucleophile or the electrophile to attach in the meta position. So we have taken concentrated nitric acid, we have taken concentrated sulfuric acid. It means we are talking about nitration, right? Whenever you see reactions that involve nitric acid and sulfuric acid, you should directly know it is nitration reaction, and in nitration reaction NO2 is used here. So this, since carboxylic acid will tell NO2 to attach in the meta position, it will get, you will get meta nitrobenzoic acid. If you are using Br2 FeBr3, you will get the bromine in the meta position. Clear? So you will get meta bromobenzoic acid. You have to remember here one thing, that carboxylic acid do not undergo Friedel-Crafts reaction because the carboxylic group is deactivating and the Lewis acid gets bonded to the carboxylic group. Okay, so whatever acid is used, it will form acyl. so it will attached here. So the reaction will not occur for the Friedel-Crafts reaction. Otherwise this two reaction is also important because it usually comes in the examination. Okay, so this thing you have to remember, and this is the last portion that we are doing for this chapter. Okay, and next we are going to start a new chapter.